Number 1, the equation of the curve is such that dy dx equals to 4x minus 3 cubed for x greater than 3. The curve passes through the point 4.5. Find the equation of the curve. To find the equation of the curve, we have to integrate the expression of the first derivative. So since we have dy dx equals to 4x minus 3 to the power of negative 3. So to find the original function, the equation of the curve from this derivative is we integrate the function. So we add the power by 1 and then we divide it with the new power. The new power is minus 3 plus 1. So this is equals to 4x minus 3 to the power of negative 2 divided by negative 2 plus c. So equals to negative 2x minus 3 to the power of negative 2 plus c. And then to find the c, we have to replace the coordinates 4, 5. So 5 equals to negative 2, 4 minus 3, negative 2 plus c. So 5 equals to negative 2 over 1 square plus c. So c equals to 7. So that means the equation will be y equals to minus 2 plus 7. That's it. Number 2. The coefficient of x4 in the expansion of x plus a to the power of 6 is p. And the coefficient of x prime in the expansion of ax 3, 4 is q. It is given that p plus q equals to 276. Find the possible values of constant a. So in the expansion of this, x plus a to the power of 6 has a general formula of 6cr x to the power of 6 minus r and a to the power of r. The first one says that the coefficient of x4. So if we see from our general form, to find the coefficient of x4, if we see from the equation, the x is coming from this term. So x to the power of 4 is 1r equal to 2. Yeah, because 6 minus r equals to 2. Or I can just rewrite as 6 minus r equals to 4. So r equals to 2. So we find that 6c2 x to the power of 4, a to the power of 2. So equals to 6c2 is 15 x4 a squared. So this one is called as, this is p, x4, yeah? So 15 a squared equals to p. This is the first equation. And then to find the coefficient of x squared from the expansion of this, so we have to make the new formula, ax plus 3, 4. This one is 4cr, ax to the power of 4 minus r, and 3 to the power of r. So to find the x squared, we can have the x is coming only from this part. So 4 minus r is equal to 2. So r is equals to 2. So that means we have to find 4c2 ax to the power of 2, 3 to the power of 2. So equals to for C2, 6 times a square x square times 9. So equals to 54 a square x square. And the coefficient is q. So this is equals to qx squared. So q equals to 54 a squared. This is the second equation. And the third equation, p plus q equals to 276. So I can put p plus q equals to 276. And then I can put p and q, 15a squared plus 54a squared equals to 276. So from here, we have 69a squared equals to 276. So a squared is 4. So a is plus minus 2. Number 3, express for x squared minus 24x plus p in the form of ax plus b, the completing the square form. So a and b are integers, c to be given, and c is to be given in the terms of constant p. So we see that the first number is 4, and the first number in the bracket is 1. So we have to factorize 4x squared minus 24x plus p. So we factorize the first two terms into 4x squared minus 6x plus p. And then we do the completing the square for this term. So it's 4. The others are the same. And then for this will become x minus 3 squared. Because this is 6, so we divide by 2 and x. So become 3 minus 3 squared. So we have 4x minus 3 squared minus 9 plus p. So 4x minus 3 squared minus 36 plus p. So we stop under here. And then next b, hence of our words, find the set of values of p for which the equation has no real root. So from here, we can see that this one is equal to 4x minus 3 squared minus 36 plus p, so equals to 0. So we can simplify x minus 3 squared equals to 36 minus p. So x minus 3 squared equals to 36 minus p over 4. And to make this equation has no real root. So that means x minus 3 is the root of 36 minus p over 4 plus and minus. And to make it has no real roots. So the number inside the square root should be negative. So that means I can say that the 36 minus p should be smaller than 0. So make it imaginary root. So p should be greater than 36. Number 4, solve the equation 8x 6 plus 215x squared minus 27 equals to 0. So I can replace x cubed in here. SA. So I have 8A squared plus 213A minus 27. It goes to 0. And then I can factorize this. This is 8A, this is A, this is 27, this is 1. So 27 times 8 equals to 216. So it's positive and minus. So we have 8A equals to 1, A equals to 1 over 8, or A is equals to negative 27. And then we return it back to the x cubed. So x cubed equals to 1 over 8. So that means x cubed equals to 2 to the power of minus 3. So x equals to 2 to the power of minus 1. So it's 1 over 2. And for this one, x cubed equals to negative 27. So that means x is the cube root of 27. So x cubed equals to negative 3 cubed. So that means x is equal to negative 3. So there are two answers. Number 5. The diagram shows the curve with equation y equals 2 for x greater than 0. The curve meets the x-axis at the point 0, 0 and 4, 0. Find the area of the shaded area. So from here we can see that the boundaries from 0 until 4. And to find the area, we can use integral from 0 until 4 of y dx. Because we are finding the area between the curve and the x-axis, so we will use y dx. So equals to integral 0 until 4, 10 x to the power of half minus 5 over 2 x 3 over 2 dx. So we have x to the power of 3 over 2, so it's 20 over 3, minus x to the power of 5 over 2, so this is 1, and then 0, 4. And then we can use 20 over 3 for 3 over 2 minus 0, 3 over 2 minus 4, 5 over 2 minus 0, 5 over 2. So we have 20 over 3 times 8 minus 2 to the power of 5, 32. So equals to 20 over 3 times 8 minus 32. So this will become 64 over 3. 21, 1 over 3. So this is the area. Number 6. The diagram shows a sector OAB of a circle with center point. Angle AOB theta radian and OP equals to AP equals to X. So this is isosceles triangle. Show that the arc length AB is to X theta cos theta. So AB is the arc length. So the arc length has the formula of arc theta in radian. So the arc is OB, and then the theta is theta. But the problem is we don't know PB. If we see from the diagram, this is an isosceles triangle. So that means we have this as theta, and this should be equals to phi minus 2 theta, this angle. And the radius of the circle is OA. So we can find this OA using the cosine rule. So from here, I can find R using this angle. So x squared will be equals to R squared plus x squared minus 2 times R times x times cos theta. So in this case, x squared, I can cancel it. So this becomes 0 equals to R squared minus 2RX cos theta. So R squared equals to 2RX cos theta. And R equals to, we can cancel this, 2x cos theta. So using the formula, S equals to R theta. So R is 2x cos theta times theta. So 2x theta cos theta. Sure, yeah? B, find the area of the shaded region ATB in terms of x and theta. So the shaded region here is the area of the sector minus the area of the triangle. So we have to find the area of the sector first. Half R squared theta. So R is 2x cos theta squared times theta equals to half 4x squared cos squared theta times theta. So 2x squared theta cos squared theta. And then for the triangle, I can use area of the triangle half times R times x sine theta. So equals to half times 2x cos theta times x sine theta. So equals to x squared cos theta sine theta. So the area of shaded region will be equals to the sector area minus area of triangle. So 2x squared theta cos squared theta minus x squared cos theta sine theta equals to, we can put x squared cos theta 2 theta cos theta minus sine theta. So this is the final answer. Seven. By first expanding cos theta plus sine theta squared, find the three solutions of the equation. So from this, we expand this one first. Cos theta sine theta squared equals to cos squared theta plus 2 cos theta sine theta plus sine squared theta. And then find the three solutions of the equation of this. So cos theta plus sine theta squared equals to 1. So that means we have cos squared theta plus 2 cos theta sine theta plus sine squared theta equals to 1. We can combine cos squared theta and sine squared theta plus 2 cos theta sine theta equals to 1. So this one becomes 1, yeah, identity. plus 2 cos theta sin theta equals to 1. So that means 2 cos theta sin theta will be equal to 0. From here, we can have cos theta equals to 0 or sin theta is equal to 0. Cos theta 0. So if we draw cos theta start from maximum and it's 0 at 90 degree. In this case, radian, so it's pi over 2 and 3 over 2 pi. It's zeros of those values. So it's on the pi over 2 or theta is 3 over 2 pi. And for sin theta is 0, we have, this is the sine graph, it's 0 at 0, pi, and 2 pi. 0, pi, and 2 pi. Since the period of the theta should be between 0 until pi only, so we only take pi over 2, 0, and pi, and ignore the other two solutions. It should be 0, pi over 2, and pi. Hence, verify that only solution of the equation cos theta plus sin theta equals to 1 are 0 and half pi. So in this case, we can just put it into the equation. So if we put theta equals to 0, so cos theta, cos 0, plus sin 0 equals to 1. Cos 0 is 1, sin 0 is 1. So this is equals to 1. Correct? And when theta equals to pi over 2, it's cos pi over 2 plus sin pi over 2. So this will be equals to cos pi over 2 is 0, sin pi over 2 is 1. So it's 1. So correct. Yeah. B, prove the identity. So from the left hand side, we need to make the denominator the same. So we multiply. So sin theta, cos theta minus sin theta per cos theta plus sin theta, cos theta minus sin theta. Plus this one multiplied by this one. 1 minus cos theta plus sin theta. So we expand sin theta cos theta minus sin square theta plus cos theta minus cos theta sin theta minus cos square theta and plus sin theta. Well, this one, the denominator can be a square minus b square. Yeah? A plus b, a minus b become a square minus b square. So cos square theta minus sin square theta. And then from here, I can see that we can cancel the cos and sin. And then I have sin square theta. So it's cos theta minus sin square theta minus cos square theta plus sin theta over, I need to change cos into sin. So using the identity, cos square is 1 minus sin square theta minus sin square theta. So I can rewrite this as cos theta plus sin theta minus sin square theta plus cos square theta over 1 minus 2 sin square theta. And this is equal to cos theta plus sin theta minus 1 over 1 minus 2 sin square theta. So this is equal to the right hand side. Using the result of A, I, and B, solve the equation. So we see that the form is the same as the previous answer. So we can change this using cos theta plus sin theta minus 1 over 1 minus 2 sin square theta. And this is equals to 2 cos theta plus sin theta minus 1. So from here we can cross multiply cos theta plus sin theta minus 1 equals to 2 cos theta plus sin theta minus 1 multiplied by 1 minus 2 sin square theta. And then I can make it the same here. So it's 2 cos theta plus sin theta minus 1 multiplied by 1 minus 2 sin square theta minus cos theta plus sin theta minus 1 equals to 0. And I can factorize this one because this is the same. So cos theta plus sin theta minus 1. So this is 2 minus 4 sin square theta. I multiply 2 inside here. And then minus 1 equals to 0. So cos theta plus sin theta equals minus 1. And then 1 minus 4 sin square theta. From here, cos theta plus sin theta equals to 1. This one has solution of this 0 and half pi. So the solutions are theta is 0, theta is half pi. And for the other, 1 minus 4 sin square theta equals to 0. So sin square theta equals to 1 over 4. So sin theta will be equals to 1 over 2 or negative 1 over 2. And then from here, the solutions are from sin theta equals to half, we will have theta is equals to sin inverse half is pi over 6 in first quadrant. And then sin positive also in second quadrant. So the angle in the second quadrant will be pi minus pi over 6. 5 over 6 pi. And then for the sine equals to negative half, it's from quadrant 3 and quadrant 4. But since the domain of the theta should be only from quadrant 1 until 2, so we can ignore these answers. So we have 4 answers, 0, pi over 6, pi over 2, and then 5 over 6 pi. Number 8. The diagram shows the graph of y equals to fx, where the function f is defined by. On the diagram above, sketch the graph of inverse. To draw the inverse function, we have to draw the mirror line. we know that the inverse function is mirrored by the y equals to x. So we draw it, y equals to x, it has the same values. So it cut here, start with pi, so like this. So this is the F inverse. Find an expression for the F inverse x. So we know that y equals to 3 plus 2 sine 1 over 4x. So we can change it, 3 plus 2 sine 1 over 4y. And then we make y as a subject. So 2 sine 1 over 4y equals to x minus 3. Sine 1 over 4y is x minus 3 over 2. So 1 over 4y is equals to sine inverse x minus 3 over 2. And y equals to 4 sine inverse x minus 3 over 2. The diagram above shows the part of the graph of the function 3 plus 2 sine 1 over 4x for negative 2 pi until 2 pi. Complete the sketch of the graph of gx in the diagram and explain whether the function g has an inverse. So if we continue from the negative one, we know that the sign has the mirror of the 0, 0. So if we have this, it will be like this. So that means we just continue the drawing, but consider the minimum and maximum. This will maximize at 3 plus 2 and minimize 3 minus 2, 1. So it should be continued and then it will reach the opposite of this. So we know that this is the principal axis. This is the amplitude. The amplitude is 2. So I have to remove the pi by 2. So it will be around here. So I can just continue this. And then this function gx has an inverse. Since gx is one function. We know, yeah, over the region negative 2 pi until 2 pi, gx is one function. So that means gx has an inverse in this period. Describe fully a sequence of 3 transformations which can be combined to transform y equals to sine x to the graph of fx, making clear order which the transformation are applied. So this equals to the first figure, yeah? So we know that the change from y equals to sine x become 1, 3, y equals to 3 plus 2 sine 1 over x, 1 over 4x. So from here we see that there are 3 transformations, yeah, 2 of stress and 1 of translation. If we have this kind of questions, we have to do the stretch first. So we mention the stretch first. So it's stretch by scale factor of 4 by x-axis, and then stretch by 2, sorry, by y-axis, and then translation by 0, 3. That's it. Number 9. The second term of the geometric progression is 16, and the sum of to infinity is 100. Find the 2 possible values of the first term. The second term of the geometric progression. So a times r for the second term equals to 16. And the sum to the infinity is equals to 100. Sum to the infinity is a, 1 minus r equals to 100. So from the first equation, I can have a equals to 16 over r. And then I can replace it here. So it's 16 over r, 1 minus r equals to 100. 16 equals to 100 r, 1 minus r. And then I can divide by 4 for both sides. I have 4 and 25. So 4 equals to 25r minus 25r squared. So we have the quadratic equation. Minus 25r plus 4 equals to 0. So we can factorize to make it 25, 5, 5, and then 4, 1. So minus 20 minus 5. So r equals to 1 over 5, or r equals to 4 over 5. Find the 2 possible values of the first term. So we find a. A is 16 over r. So 16 over 1 over 5 equals to 80, or 16 over 4 over 5 equals to 20. B. Show that the nth term of one of the 2 possible geometric progressions is equal to multiplied by the nth term of the other geometric progression. So we have A is 80, and another one, A, is 20. The ratio 1 over 5 for 80, and this one, the ratio is 4 over 5. And then we have to show that the n term, the un, of one of the 2 possible geometric progressions is equal by the n term of the other geometric progression. So we have to find the un here equals to 80 times 1 over 5 to the power of n minus 1. And the other un for the other progressions is 20 times 4 over 5 to the power of n minus 1. And then we try to express this. So I give the name A and B, and then I can just do the ratio. So UMA and UMB is 80, 1 over 5, n minus 1, 20, 4 over 5, n minus 1. So this is 4. So UMA over UMB equals to 4, 1 over 5, n minus 1, over 4, n minus 1, times 1 over 5, n minus 1. So this is the same. So I can make it into UMA, UMB is 4 over 4n over 4. So equals to 16 or 4 square over 4n. So this is UMA over UMB equals to 4, 2 minus n. So if we want to express in this form, so I have to make UMB is equals to 4 n minus 2 UMA. Yeah, from here, UMA is equals to 4, 2 minus n UMB. So that means UMB is 4 n minus 2 UMA. Number 10, the equation of the circle and the line is a tangent to the circle at the point P. Show that one possible value of A is 4 and find the other possible value. So line of this is a tangent, so we can just replace it to the equation. So x minus a squared plus half x plus 6 minus 3 squared equals to 20. And then x squared minus 2ax plus a squared plus, or we can simplify this, plus 3 squared. So 1 over 4x squared plus 3x plus 9 equals to 20. So we have 5 over 4x squared plus 3 minus 2ax, and then plus a squared minus 11 equals to 0. And then I multiply all by 4. 5x squared plus 4, 3 minus 2ax plus 4a squared minus 44 equals to 0. And since the line is a tangent, so from this quadratic equation, I can have discriminant equals to 0. So b squared minus 4ac equals to 0. So 4, 3 minus 2a squared minus 4ac. So from here, I have 16, 9 minus 12x a plus 4a squared minus 20 times 4, 80a squared plus 20 times 44. So 880, yeah, equals to 0. And then I have to simplify this. Okay, just divide everything by 8. That's 16. So 9 minus 12a plus 4a squared minus 5a squared plus 55. So I have minus a squared minus 12a plus 64. So a squared plus 12a minus 64 equals to 0. So this is 4 and 16. So plus and minus. So a equals to 4 or a equals to negative 16. So shown, yeah? Next, for a equals to 4, find the equation of the normal to the circle at P. We know that the equation of the circle is x minus a. So a is 4, so x minus 4 squared plus y minus 3 squared equals to 20. Yeah, the equation is x minus a squared plus y minus 3 squared equals to 20. Since a are 4 and negative 16, but we use a equals to 4 here, so x minus 4 squared plus y minus 3 squared equals to 20. So that means the circle has the center of 4, 3. Find the equation of the normal to the circle at P. So if we draw the circle, and there's a tangent here, y equals to half x plus 6. So the gradient of the tangent will be half x. That means the normal to the circle at P will pass through the center of the circle. So that means the gradient of the normal will be equals to negative 2. And since the line is passed through the coordinate of the center, so we can construct the equation of the line minus 2x plus c using the center coordinate. So it's 3, negative 2, 4 plus c equals to negative 8 plus c. So c equals to 11. So that means y equals to minus 2x plus 11. That's for the B. Next, for a equals to 4, find the equation of two tangents of the circle which parallel to the normal found in B. So the tangent parallel to the normal, we have two tangents here and here. Yeah? So the gradient of the tangent should be equals to minus 2. So the equation of the tangent now is y equals to minus 2x plus c. And we have to find the coordinate of the intersection, so we replace it to the equation of the circle. So it's x minus 4 squared plus y minus 2x plus c minus 3 squared equals to 20. And then we expand this, x squared minus 8x plus 16, and then plus 4x squared minus 4cx plus 12x minus 6c plus c squared plus 9 equals to 20. And then simplify 5x squared and then plus 4x and negative 4cx can be combined. And then plus c squared minus 6c minus plus 16 plus 9 plus 25 minus 20 plus 5 equals to 0. So to find the tangent, the discriminant from this quadratic equation should be equals to 0. So that means we have b squared minus 4ac. Like this. And then I can simplify. So I put the 4 out here. 4, this is 4. 1 minus c squared minus 4 times 5 c squared minus 6c plus 5 equals to 0. So 16, 1 minus c. Minus 6c plus 5 equals to 0. And then I divide all by 4. I have 4. And then I expand 1 minus 2c plus c squared minus 5c squared plus 30c minus 25 equals to 0. So 4c squared minus 8c plus 4 minus 5c squared plus 30c minus 25. So minus c squared plus 22c minus 21 equals to 0, or c squared minus 22c plus 21 equals to 0. So c minus 21 and c minus 1 equals to 0. So c equals to 21 or c equals to 1. So the equation of the line will be y equals to minus 2x plus 21 or y equals to minus 2x plus 1. That's for number done. Next, 11. The equation of the curve is, where k is positive constant, find dy dx. So we have y equals to k for x plus 1 half minus x plus 5. So the dy dx will be equals to k times half for x plus 1 negative 1 over 2 times 4 minus 1. The 4 is coming from the derivative of this. So equals to 2k for x plus 1 negative half minus 1. Find the x-coordinate of the stationary point in terms of k. The stationary point when the dy dx equals to 0. So 2k for x plus 1 negative half minus 1 equals to 0. So that means 2k over for x plus 1 equals to 1. So for x plus 1 half equals to 2k. So for x plus 1 is equals to 2k squared. So for k squared, yeah, we square it. So for x equals to 4k squared minus 1 x equals to 4k squared minus 1 over 4. And then given that k is 10.5, find the equation of the normal to the curve at the point where the tangent to the curve make an angle of tan inverse 2 with the positive x-axis. So if we have the curve, and it says that the tangent has the theta here with the gradient of tangent minus 1, 2. So that means this will be the gradient of the tangent. So the m is equals to 2. Yeah, because m is the rise over run. This is y, this is x. So m is rise over run. And tangent is also y over x. So that means the gradient is equals to tangent theta. In this case, the value of the tangent theta is 2. Because the inverse tangent is equals to 2, so that means the tangent theta is 2. So the gradient is 2. So we use the equation of the derivative. 2k for x plus 1. So 2k for x plus 1 minus half minus 1 equals to divided dx. And this is equals to 2. And then we put that k is 10.5. So it's become 21 for x plus 1 negative half equals to 3. So for x plus 1 negative half equals to 1 over 7. So 4x plus 1 to the power of half is equals to 7. That means 4x plus 1 equals to 7 squared. 4x plus 1 equals to 49. So 4x equals to 48. X equals to 12. So x equals to 12 and y equals to, we put it into the original function, k root 4x plus 1, k root 4x plus 1 minus x plus 5. And then put the x is 12, 49 minus 12 plus 5. So 10.5 times 7, so it's 73.5 minus 12 plus 5 equals to 66.5. This is the y. And then find the equation of the normal. So we know that the gradient of the tangent is 2. So the gradient of the normal will be equals to negative 1 over 2. So the equation will be y equals to negative 1 over 2x plus c. And we put the coordinates 12 and 66.5. So 66.5 equals to negative half 12 plus c, negative 6 plus c. So c is 72.5. So y equals to minus half x plus 72.5. So this is equation of the normal. And this is the last question in the past paper in this exam. Thank you for watching. Bye.